Cool. So this talk is really a presentation of a white paper that I put together for business managers in my context. I'm working at a healthcare company, and over this past year, especially, agentic AI has been this huge buzzword that's gone around everywhere, and all business leaders want to stay on top of that word, but there isn't a lot of clarity on what does that word exactly mean. I don't think that's peculiar to the industry context where I'm in, but we probably have our own peculiar difficulties with it that might not appear in the more academic and research spaces that a lot of the context of the other talks here are. So I'd be especially eager for discussion and insight from how does the terminology work from the different contexts where you all are coming from, different than where I'm coming from. But here's basically presentation of the experiences that I've had and the way I've seen the terms used and ways of navigating them. So here's some examples of official publications or interviews that have given different conflicting definitions of the word agent. I don't read through all of these, but the one of the tops from Amazon's page about agents, it's AI agent is software that can interact with its environment, collect data, etc. AI agents are rational agents, it says. The next one down from UiPath, which makes robotic process automation tools. Agents are software robots that use AI skills to accomplish more complex tasks by including abilities for task planning and autonomous decision making. That doesn't actually help me pin down what does an agent mean, but it's a very lofty sounding definition. Or agents are applications that use generative AI models to think and act towards goals, and so on. So like these are different definitions. So how do we navigate? What does agent mean? As Ethan Mollick says, the confusion in the marketplace over what agents are is even worse than the previous confusion over what AI is. At least with AI, there were some definitions we generally agreed on, but now everyone is just calling every piece of software agentic, and there is no common understanding to fall back on. So that definitely characterizes the environment that I'm in the healthcare industry. So what are the definitions out there? Here's the rough outline of my talk. I've identified 4 general classes of the way I've seen the term used. And I'm only really going to have time to talk about textbook agent, which means Russell and Norvig specifically, and then the LLM agent, because those are the 2 most precise ones anyway, the ones that most come up. And then as time allows, I would like to have some discussion about maybe there's a way of unifying the main definitions that people are trying to get at. And so I have a proposal for like, well, okay, there's another way we could use the word agentic perhaps. But I have a lot of content to try to breeze through. So the outline here, I'll start with, what is the textbook agent? It's basically, what is the Russell and Norvig definition? The second one, multi-agent agent. So this is kind of a peculiar one, but basically where people describe agents as multi-agent systems without a lot of clarity as far as how is the multi-agent system itself an agent, or is it, or etc. That's not very well defined. Then there's the human-like decision agent, which is more of a broad family of different types of definitions of agent, but they are largely fairly vague. But it's relative to, well, we have this imagination of how humans would do this thing, and the more human-like it is, that makes it more agentic. So that's a hard one to pin down as well. But then there's LLM agent, which can be more precise as a definition, but it's also a lot more constrained than the textbook agent, which is agents are LLMs that can take actions using tools. And that's much more easy to measure. But it has some difficulties when you try to push it to its limits, which I'll talk about. So first, some review of the textbook agent, which has been discussed in previous talks, but this goes back to that Amazon definition. They make rational decisions based on their perceptions and data to produce optimal performance and results. So just some quotes from the Russell and Norvig textbook, the 2021 edition. Agent is just something that acts, from the Latin agere, to do. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. And then we have a rational agent, which is an agent that acts so as to achieve the best outcome, or when there is uncertainty, the best expected outcome. And artificial intelligence as a field is the study and creation of rational agents. So going to this textbook definition, it's part and parcel with even just the study of AI as a whole, the way the textbook approaches that definition. So it's what counts as an agent. Well, you can make an argument that almost anything with IO counts as an agent. They say in the textbook, one could view a handheld calculator as an agent that chooses the action of displaying 4 when given the percept sequence 2 plus 2 equals ... In a sense, all areas of engineering can be seen as designing artifacts that interact with the world. AI operates at what the authors consider to be the most interesting end of the spectrum, where the artifacts have significant computational resources and the task environment requires non-trivial decision-making. So this is the textbook definition, and it's very easy to measure and apply to things, but it's not very satisfying to the average person on the street who doesn't want to view a handheld calculator as an agent. So there's that. There's multi-agent agent, which for time's sake, I'm not going to dive into, but I don't actually encounter people writing this one out as like a formal definition. But rather what I see is like business presentations, people will use multi-agent systems as like the defining exemplar for this is what agents are. And they'll use sloppily language that basically makes them equivalent. So I include this here more because of, I think, sloppiness and how people speak rather than because this is what people would formally define agent as. So something to watch out for in conversations. Then there's the human-like decision agent. Again, I'm not going to have time to go into this one. If anyone wants, I can forward the paper that I wrote about it. But it's also not very crisply defined. It's more just a general sense of this is what I want agent to mean in certain example cases, but there isn't a easy definition to actually pin down and then push to its edge cases. But then there's the LLM agent, which I'd like to talk about more, because that is by far the most common sense of agent that is now dominating the industry conversation. You take an LLM, this is a quote from Victor Dibia. I think, yeah. So you take an LLM, you give it tool calling capabilities, you give it the ability to execute the result of those tool calls, and then you have an agent. I feel like I'm happy with that base definition. So that's kind of the general sense that is floating around. So talking more about, well, how does LLM agent definition work? So it defines an agent in terms of its internal design rather than external function. It reduces agent to software that uses LLMs as decision-making algorithms. So that would rule out something like Soar that's not using LLMs to do its decision cycle primarily. It would also rule out a lot of other, pretty much any kind of agent-based research in software that predates LLMs. Now, LLM agents are typically programmed through prompts, as I think we're most of us familiar with. For example, you're an expert writer, write an essay topic about fill in topic variable here. In conversations that I have been privy to in business, it's often implicitly combined or equivocated with other senses of agent out there. I think because of a lot of ignorance that the word agent existed prior to LLMs. Sometimes it's described using Russell and Norvig's classification of 5 types of agents, which is a bit of a contradiction because the 5-type classification from the textbook relies on the Russell and Norvig definition of what agent is. But you'll have presentations that have the starting point of this is what agent means. It's an LLM agent. And then you have all these 5 types of agents, which actually rule out LLMs in some cases. So there's contradictions there. Sometimes it's described as equivalent to multi-agent systems. Sometimes LLM agents are described as equivalent to tech that replaces skilled human workers, getting more at the idea of, well, it's something that's being more human-like as the definition of agent. So the way people treat the term LLM agent or agentic in this sense is also still a little fast and loose in my experience. Part of the difficulty here is how do we actually define what differentiates one LLM agent from another? So you might perhaps say that you can differentiate one agent from another because they use different prompt templates. So if you have an agent prompt that's, write an essay about fill in the blank here, you might have one filled in instantiated prompt template that's write about flavonoids, and that's agent A. And then you could use that same template to say, write about free radicals from non-ionizing radiation. And you would still say that that's agent A because it's using the same template under this option of definition. You have a different template that's review this article for grammar, and you give it an article, then that would be a different agent. That's agent B. So maybe that could work, but then what if you run one prompt template with two tasks in parallel? Do you still say that that's a single agent that's doing two things at once with like two different instances of itself? That doesn't sound right. So probably not this definition of what differentiates two different agents. Nevertheless, I want to point out that on at least what I've encountered as far as like agentic branded software, usually they just define agent in terms of the prompt template if they define it at all. So I think there's some sloppiness there. Another option, well, it's a different agent if they're running different tasks, like different processes. So if you tell one template, write about flavonoids, that's agent A. If you ask the same template to do a different task, write about a different topic, that's a different agent, that's agent B. And then, of course, you have agent C doing a different prompt and template entirely. But then, well, every use of one template is considered a new agent. And so at that point, there's, that doesn't sound right either. You could have one template, write a text about this, but then every time you use it, it's a different agent. And that's not how people talk about agentic software either. So there's another option, which I think probably gets more at what people have in mind, which is that it's about maintaining memory state. And this especially, I think, brings to mind chatbot situations where you can have parallel uses as different agents, but sequential uses that could be the same agent if they're maintaining the same memory context. So with a chatbot, you have a few interactions, you come to it later, and it might still have that context to the memory of the previous things that were said in the conversation. And so that's, it's like you're talking with the same agent. I think that's kind of the idea people have in mind. Problem is with agentic software, the quote unquote LLM agents, as I think I encounter most people talking about them, those don't actually have individual state memory. The chatbot context is actually not that common in terms of like business operations. You're having more like API style interactions where you like want it to process a document or things like that, and then have different agents like in a multi-agent system that are processing different aspects of a long workflow pipeline. And so you're not having like a chat interaction. You're just dividing a large piece of work into sub pieces of work. And so in that sense, most of what the industry calls agentic AI would not actually count as using different agents for each interaction because there isn't the individual memory. There are shared memory contexts, but that's not the same thing. With shared memory, you can have one agent passing off its output to another agent's input and things like that. But that's not the same thing as saying that the one agent is maintaining a longer memory context of interactions. I mean, you could maybe argue that point, but in any case, I think there's a lack of consistency or precision in how we differentiate what different agents are in terms of LLMs. And so there, I would like to pivot to, well, can we bring these different definitions together in a way that is more satisfying, but also more technically robust? And this is now just pivoting to my own personal musings. So welcoming discussion on this point. So we have two different aims. We have the textbook definition, which is more consistent and robust. You can push it to its limits, and it's useful for technical conversation, but not so satisfying. And we have the non-textbook definitions, which are not very robust, but more at a gut level satisfying. So, and given that we already have the chaos of the different competing definitions, maybe we ought to try to introduce some unifying definition that actually accomplishes all of the aims. So here is what I would propose, and I specifically use the word agentic here rather than agent because it's a newer term anyway that's less well defined, but the two kind of go together, I think. But agentic as something is agentic when it acts to change the IO relationship that it has with its outside environment. And I'll talk about what do I mean by that. So compare with the textbook agent definition is similar, that it's based on the presence of IO with an environment, but dissimilar in that it requires a particular kind of IO, or specifically a kind of output. So if I were to make a table of how do the different definitions line up on different exemplars, you have a robot that folds laundry, a laptop sitting on a table, LLM-based tool-using app, network router that's managing different packets going through and where to route them to, and computer server clusters that are spinning up and spinning down different like worker servers and things like that, and assigning jobs to them. Textbook agent, everything's an agent. LLM agent, only LLM's an agent. By the proposed definition, the robot and the LLM agent would, I think, count as agents and the others would not, which I think matches, at least with my understanding of the gut sense of what we want to call an agent. So some examples of how this plays out. So you have a 3D world, say you've got a laptop computer sitting there and a walking robot. The laptop, its input is constrained by where and how it is used. So it has a camera, it has a keyboard, but it can only see things in the world that are shown to it in its camera. If it was set on the top of a bench pointing at a tree, it could see anything that happens in that tree. And there might be lots of things that at different times that come into its field of view, but it can't control what its field of view is. The robot, on the other hand, can move. And by moving, it can change not only what its current input is, but the space of possible inputs that it can receive. If it's looking at the tree, it can see anything that's going to happen at the tree. But if it turns to look at the lake, now suddenly it can see a whole different space of possible inputs. And that is what I would say is the core of what we're getting at when we talk about agency. The laptop can receive different things if it is moved, but it cannot itself move itself to change that input space, whereas the robot can. Going more virtual, you have the managed master-slave server cluster setup, and you have agentic LLM software. The master node server setup, it can receive all sorts of different inputs, but it's not changing on its own in the general example what kinds of inputs it's receiving. Whereas the LLM software, if it has a tool that lets it navigate the internet, then suddenly it is able to change what kind of inputs it's receiving by navigating to a different web page, or changing what kind of outputs it can give by similarly opening a web page that has different web forms that it can output into. So while the cluster lacks agency, the LLM actually has agency because it can change its inputs and its outputs based on the abilities of its tools. And this leads to some interesting implications as far as terminology goes. You have the distinction between the current IO space, like what your robot can ever see if it stays put, like looking at a tree, and then the space of possible spaces that it can reach using its known actions. If it's walking in a 2D space, it can see anything from the ground that it can walk to. And that's space of possible input spaces. But that space is constrained. If it can only walk the surface of the ground, it can never fly. It can never see what the world looks like from a 1,000-foot view. If it gets stuck in the mud, also there's a different kind of constraint. Now it can no longer move, and it loses that kind of agency. So similarly, the LLM agent, if it can crawl the internet, it has agency in that sense to change its input and output. But if it only has tools to do simple math, now it can't navigate the internet, it loses agency. So the tools at the LLM's disposal are what are actually giving it agency. And if it doesn't have the right kind of tools, it might not qualify as an agent. But then there's a second derivative. You have the space of possible spaces you can reach with known actions, but then there's also the space of possible spaces that you can reach with actions that you can learn. So if your robot is stuck in the mud and it has a shovel, maybe it doesn't know how to use the shovel. But if it can learn how to use the shovel, now it can learn how to gain action that gives it agency. Similarly, if it can learn how to build a jetpack, now it can suddenly use that jetpack to fly, and it has increased the space of spaces that in a way that it didn't have before because it learned a new type of action. So learning thus can enable agency. Learning itself doesn't necessarily have to imply agency, but if that learning allows you to take your starting IO space and actions specifically and use those to unlock new IO spaces, then learning enables agency. So main takeaways from that, as far as I can tell, looking at this definition, it seems to hold together and still satisfy what I think is the gut sense of what people are aiming at with talking about agentic software. And it has, I think, some useful theoretical connections with terminology. And either way, we can say it's up to the AI developer to responsibly give AI the right tools for the spaces that it can explore and the right constraints for what it can and should learn to use. But that's as far as this end of discussion goes. And so I know I'm running out of time. So just conclusion, nuggets of recognizing the different ways that agentic AI is used and defined helps us navigate confusing conversations. And so the four main definitions presented here are useful for, I think, navigating business conversations, especially to figure out, well, what do people mean and can we be more precise in how we use those? And then there's a proposed definition for potentially unifying different schools of thought. Cole is the confusion over the term agentic isn't going away anytime soon. And the presented definitions are definitely just characterizations of how I've seen it used in the past year, especially. Individual usage can vary or can combine different presented definition forms. And the presented proposed definition definitely adds to the many out there. But I think that some new unifying definition that satisfies public sensibilities might be necessary, given that it now is a more public discourse topic. And this definition hasn't really been put to the test, so I'm open and eager for a discussion on that front as time allows. But that is it for my presentation. So do we have any time for questions?
Yes, so we'll go until 5 after. I do have one comment, Bryan. One of the things I've just seen in the last maybe 6 months is the term, there's a subcategory of agent, which is something that represents you and goes out and does things on your behalf. And it seems like that's coming more and more from some of the big tech companies. Are you familiar with that, or is this a misinterpretation on my part?
So I have seen that kind of usage mentioned. It's usually not coupled with any kind of more formal definition. I think this last one here from Medium might be kind of in that category.
Okay.
It tends to be like a more lofty definition that I encounter. I tend to group that along with like the human-like decision agent, which I didn't go into much detail on, but maybe that does merit its own category. So I think you could argue perhaps that that's another instance of even the calculator, if you wanted it to be, it's doing summation when you want it to. But that's a good discussion point.
Right. I mean, I see that as sort of the outfacing definition of agent that companies are using, as opposed to the interior. Here's how we design agentic systems. They're talking about, oh, we have an agent that will make reservation for you at a restaurant.
Well, it's like an assistant.
Assistant. It's like an assistant.
Yeah.
So I've just seen that anyway.
This might be a little dark. How would you characterize when you succumb to learned helplessness?
Learned lack of agency, as it were, I guess. If your learning leads you to no longer be effectively able to interact with the world and change your IO, then I guess, yeah, you could say that learning can both enable agency and then remove agency.
I was wondering if you asked about humans or about AI.
Yep.
Yeah.